talk. Our next guest is from Paracosm, and Paracosm wants to 3Dify the world, I think, is one of their goals. They're also a partner with Google Tango, Project Tango. So please welcome Gannon Wilkins. Thanks.
How you doing? My name is Gannon. I'm head of business development at Paracosm. Sorry, Mir wasn't able to make it. He had some hiccups with flights and ice on the East Coast, so I'm taking over for today. But what I want to do today is share basically our vision for how Paracosm can enable new types of experiences using 3D maps. Now, what kind of experiences? The big vision of the smart home, something futuristic of smart appliances, Internet of Things. You have robots running around doing chores for you while your kids are playing with their augmented reality app with a dinosaur chasing them through the hallways. And you guys are probably looking at me like I'm crazy right now, saying, what do these three things have to do with reality capture? But what they have to do with it is they're all tied together by 3D maps. 3D maps enable all these experiences to come about. Robots can now navigate more smartly and intelligently throughout a space once they have a pre-scanned map to navigate. Augmented reality can now break free or be in larger scale spaces existing in your physical home and not just more in like small targeted areas. So I'll share more about some of these things in a bit. But essentially what Paracosm does is using these 3D depth sensors, we scan, create models. We're cloud-based, so you upload it, it processes in the cloud. And then you can move on and build applications on top of it, like some of these exciting experiences I was talking about before. Like Brian mentioned, we did help in the development of the Google Project Tango for about 9 months. We were working with that team before it was launched, and we contributed some dense mapping to it. So essentially, the first step you do is the capture side. You guys are probably familiar with this. You've probably seen a lot of examples. You essentially just take a camera like this, walk around, kind of like you're taking a video of your home, and you can scan a space. Then after that, you can upload it to the cloud. And our cloud, how it works is it stitches all these individual frames together into one cohesive model. And so this is not actually what happens, but it's a, it's not scientific, but it's a fun way to show what happens. And the power of processing on the cloud versus the device is you're able to capture much larger areas as well as do collaborative scanning. So I'll explain two of those things in just a second. Here, this is just a couple fun scans some of our clients and users have taken of pipe rooms. Any MEP nerds in here, you'll love this. These are a lot of, the unique part of a handheld scanner is you're able to really get, all around the edges, capture the full space of an area. So that's a fun example of what we've done. Like I said, one of the powers of doing processing in the cloud is you're able to capture large scale spaces. So on device, a lot of times you're limited to small areas, maybe like 50, 100 square foot space at the max, at best, at this moment. But when you process in the cloud, you're able to maybe capture space like this, 5,000 square feet from a handheld device. And this was taken by one man it was under a day. I think it was just shy under a full day. But yeah, he got up in there and every single cubicle, be able to capture. If this was a live model, you could zoom in and see who had the messiest desk. It's kind of fun to explore the office. But yeah, capture the cubicles, break room, office spaces, cafeteria. And this was all separate scans uploaded into one thing. Now, if you guys have explored this area around here, you'll see there's a cool bar right around the corner called The Interval. There was a social there last night. But so yesterday during lunch, I walked through there, and it was during the day, and they actually had customers and things, so I actually had to take several like smaller scans, or like somebody walked by, so I like stopped and then like resumed later. So total was probably only like 5 minutes, but I probably took a couple, like 1 minute, just like waving things. And it's just kind of cool example showing the collaborative nature of it. That it wasn't just one single scan, and I wasn't processing on the device as I was scanning, but I was able to capture several areas, and then later just upload it and bring it together. I think this video just scrolls around for a bit. So bringing it back to the smart home, I mentioned a lot of, made some big claims at the beginning and then showed you a lot of maps. So next I want to share how maps are a crucial part to enabling these applications. As I mentioned, a robot navigation. The current state of the art for robots is there's all different types of SLAM. But essentially the maps that they create as they go around is not a persistent. The maps aren't saved. So by having a pre-scanned environment, the robot can then know exactly where it is within the space, know everything else in the peripheral of where it's going, and localize its current location according to that. So this is just a fun little example. From a pre-scanned map, you say, hey, go to this location, and now the robot already knows exactly where it is in the room. You could say it almost understands that as a human would understand its spatial presence in a space. And it just is able to automatically drive there. And you can see this is a little Roomba and a little Tango, you know. So that's a fun application. And the implications of this is now your home cleaning robot devices, they won't bounce around in the walls and hit things. You could say it makes it smart, or they know where they're going now. And also, there's a whole new horizon of medical devices, of robots, remote presence, going through hospitals and things to patients. So that was the robotic side, and I mentioned a couple other smart home futuristic things. The other area is more in the virtual reality, augmented reality space. Because in the same way that a robot can then know where it is in a map and localize against that map, a handheld device can then know where it is in a room and localize against itself in that room. So this, we're not video game designers, this isn't anything extraordinary, but this is a dinosaur running through the hallway. And imagine your little kids being chased by the dinosaur, it's augmented, and it's not just in one area, but it's living throughout your entire house. And we do that by, like I said, localizing where the device is currently against the pre-scan model. So you can see here's just a cheap little gorilla, but behind it, it's actually sitting on a mesh, the captured model that you've created. So that's, that's basically shows our vision of it's not, your device is now not tracking individual objects or scanning individual objects, but it's more bigger scale. It's the whole area. So that is all. Thanks for listening.
Thanks, Gannon. So great stuff. I think we're all seeing a trend here with mobile mapping technologies come to life, and it's really exciting. I think it's also, in addition to robotics technologies, entertainment, but even just being able to map things out really quickly and see how things change over time, it's really interesting. So great stuff.